Hello,
Yes, yes.
hello.
G G.
I can't hear you.
Hello.
Is it better now?
G G, it's better.
Okay, so I was talking about the bromine test which we used to do in O levels. That was meant to identify whether we are discussing, let's say, a saturated hydrocarbon, if you remember, alkane, or an unsaturated hydrocarbon, if you remember, that was an alkene. So it used to decolorize in an alkene. Do you remember doing any test like that?
Yes.
So initially, we used to have some chemical reagents that were used to identify organic functional groups. So now, since we are in A levels, we don't do that anymore. What we do is some, mechanical tests, some physical tests. So the idea is that if there is a functional group in my organic compound, so that functional group will absorb certain amount of energy, and if I can figure that out, that what amount of energy is being absorbed by the functional group, so I might be able to identify that what functional group is present in my hydrocarbon. So this technique basically is infrared spectroscopy. We get this.
Yes.
So every functional group, be it alcohol, be it aldehyde, be it ketone, be it alkene, be it anything, it only absorbs a certain amount of energy. It's like, I used to explain this in a sense that, for example, if my favorite food is, let's say, a chicken sandwich. So if someone offers me, a beef sandwich, so since I don't like it, so I won't have it. I would only like to have chicken sandwich because that's my identification. That is what I love. So if you are finding out alcohol, if you are finding out carboxylic, if you are finding out ketone, so every functional group will absorb only a certain wavelength, and that certain wavelength, using physics, using some equipment of physics, we can find that out, that okay, this is the wavelength that is being absorbed, and all the physicists, they have compiled that this much amount of energy is absorbed by certain functional groups. So you can see this on my screen. So that's how we identify functional groups in A levels. Do you get this now?
Yes.
Okay. So the frequency generator, which a device which basically sends a signal to an organic compound, is a spectrophotometer. This is what is written here. It kind of sends a signal, and that signal, if it is in the range, gets absorbed by my functional group. And if that my functional group absorbs it, so it becomes a resonance frequency. And this enables the functional group to vibrate more, energetically, to vibrate with more intensity. And ultimately, my organic compound might decompose, might break, or it might not break. So that depends on how much signal or how much energy we have supplied. It's like, if you energize a hydrocarbon, so initially it absorbs energy. And if you keep on energizing it, so maybe the supplied energy exceeds the bond energy. So if that exceeds the bond energy, so what would happen? It will break. You get this?
Yes.
Now, the process is again analytical chemistry and infrared spectroscopy and all. So we have discussed this now. And this would be given in your CI. So you don't need to learn this. So just for your understanding, what is, this shows? This shows that if my organic functional group is carbon and oxygen, so it might be a hydroxy or ester. And the wave number is reciprocal of wavelength. That is 1 over wavelength. So if you remember wavelength in physics, so wavelength was supposed to mean what? Wavelength was supposed to mean length of a wave, right? Or it represent energy, right? So if I'm supplying energy, so this energy is basically absorbed by these functional groups, and then the energy range is changing for different functional groups. You get this?
Yes.
So let's say, if we talk about, there are two hydrocarbons, one is an A and the other one is B, and the hydrocarbon A, is supplied with energy. You can see this here. That's the energy which we are supplying, and then there is a dip here, and then there is a dip here, and then there is a dip here, here, and then there are total random dips. So this is basically what my hydrocarbon is absorbing. So this is basically an infrared spectrometer graph what I've plotted. Okay. So this is for some sample A. How would I check that my functional group is absorbing, what kind of hydrocarbon is having my different functional group? So I would see the most steeper dip. So if you compare all of these, here, here, you find the best steep here, right? It's the longest peak.
Yes.
So if we can read this value here, so this is 1500, right? And then 1600, 1700, and 1800. So it's somewhere between 1700 to 1800. Makes sense?
Yes.
And then I'm ignoring all of the remaining hydrocarbons because, they might not be the original compound which I'm studying. So the idea is we have to study the only deepest peak. You get this?
Okay.
So we are not going to see what's the value here, what's the value here. We don't care about that. The only thing we care about is the steepest decline. Similarly, if you see sample B, so here most students identify that deepest peak is here, right? It is the deepest peak, but it's not the only peak. It is having multiple peaks. So we kind of never have these multiple peaks. So if we are deciding that that's the steepest peak. So that's correct. But since it is having multiple peaks, so we are not considering this. We have to leave it evaluated. The second most reasonable peak to have is this, and that's a stretch. It's not a peak; it's a stretch because it requires we can say a large amount of energy. So maybe a functional group here can have a double bond or it can have a triple bond. That is indicated by a lot of energy required to spread this out. Do you get this?
Yes.
So if we read this, so this kind of range from that's 3000. So that's 3100, 3200, 33, 34, 35, 36. So it has to be around 3200 to 3600. Do you get this?
G.
So we can say, comparing on this table, that the first one was something around 1700 to 1800, and the other one is 3200 to 36. So 1700 to 1800 is
I
might
might.
right, and then 3200 to 3600 might be right. Makes sense.
Yes.
But there may be different ranges. Maybe some students identify this as a range. So the question normally gives us a hint. It never asks us, okay, identify whatever the compound is. They would ask us the question something like this, that let's say these two samples A and B are, one is a ketone and the other one is an alcohol. Now they have cut short a very versatile range to a specific functional group. So if they say identify which of these is ketone and which of these is alcohol, then it becomes very easy for us. Okay, bhai, this is alcohol, right? This makes sense because it lies in the range. Yo,
Yes.
we get this.
Yes.
So A is a propanol, that's a ketone, and B is an alcohol. That is what we have done. So that explains what I was discussing with you. Do you get this part?
Yes.
So do you find it difficult or easy?
Easy.
It's understood. It's clear.
Ye- Yes.
Are you sure? Any questions?
Yes. No.
Okay. Then if we move on to the other techniques, the spectroscopy might not be always suitable technique. There are different techniques. So we can use different techniques to identify multiple organic compounds. So one of the techniques may be infrared spectroscopy. The other one can be mass spectrometry and all. So the part where we used to think that there is a hydrocarbon molecule and we supply it with some energy. So if we supplied some energy, then what happens? This molecule, it kind of become an ion, right? And then the ion here can undergo, this is known as molecular fragmentation. That's the best picture we can find on internet, to explain it. The molecular fragmentation is, we have broken a molecule up. So we now don't have any idea that the molecule will undergo what kind of decay. It may become, a simple molecule and an ion. It may become a free radical and a cation. It may become a cation and a free radical and a molecule. So it depends on multiple things. It depends on what the nature of the original molecule was. But what we know for sure is if we are supplying energy to any molecule, it will be ionized and it will have molecular fragmentation. Do you get this part?
Yes.
That's what. So this is what we have so far discussed. So in AS chemistry, you're meant to discuss basically three different behaviors. One is for the isotope of chlorine, and if you remember, we started discussing this basically subject with relative atomic mass calculation (AR) calculation, and there we used to have some relative abundance and things like that. Do you recall that?
Yes.
So chlorine has two isotopes, 1735 and 1737. So if we have an hydrocarbon that basically, contains a chlorine functional group, let's say we have a hydrocarbon that shows an alkyl halide, right? So there is a 25% chance that it may be chlorine 37, and it is, having a 75% chance that it is chlorine 35. So if we break this up, we can have chlorine 1735 as ionized. Maybe, it can become chlorine plus one. And if we have chlorine 37, so we can have an ionization of plus two. So we can expect basically two different peaks on that E by M or charge to mass spectra we used to study. So this is what I mean by this. For example, if we have two isotopes of anything, so we can expect two different peaks. Do you get this?
Yes.
This graph basically is showing two different peaks. So since it's atomic number 10 and 11, so it's not chlorine because chlorine has to have 17 and 35 and 17 and 37. So what does this isotope show? It's showing boron. So boron is 10 and 11. सही है? Okay. Then the other part is the highest peak is basically the base peak. And the peak, next to it, maybe an M plus one peak. If there is a difference of one atomic number, you can identify कि इन दोनों में एक का फर्क है. If we talk about chlorine, which has to have 1735, and then chlorine 1737. So that would be M plus 2p. And it may be कि कोई ऐसा आइसोटोप हो जिसमें 3 या 4 का फर्क हो. लेट्स से कार्बन एक होता है 612, एक होता है 613. तो इसमें भी M और M plus 1 peak मिल जाएगी. Do you get this logic?
Yes.
That makes good. So let's talk about ये तो फजूल सी बात. So we don't care about this. ये मैंने आपसे डिस्कस कर लिया. Right. So it says determine whether the following mass spectrum corresponds to propanol or butanol. ठीक है. So propanol contains 3 carbon and it's an alcohol. Make sense? Or it's an aldehyde.
Yes.
An alcohol, it's an aldehyde. So it should be CN H2N plus 1. बल्कि आपको ये तो और चैलेंजिंग हो जाएगा. तो प्रोपानॉल होना चाहिए something like this. And butanol होना चाहिए something like this. Butanol will have 4 carbons, right?
Yes.
The remaining valencies would be filled by hydrogen. So they say we have to identify that this spectrum represents propanol or butanol. So how would we identify it? We need to work on the molecular mass. So if I ask you, based on this structure, would you be able to calculate the molecular mass if I give you that carbon has a mass 12, hydrogen has a mass 1, oxygen has 16?
Yes, I think so. One second. I have to calculate mass, right? Molar mass?
Molecular mass, it's not molar mass.
Okay, okay.
So this is molar mass 58. And this is molar mass 72. So you have these answers with you?
Yes.
Okay, good. So if we figure this out, these two values, then on x-axis we can find that this represents a mass 15, that represents something around 17. This is from 25 to 30, this is from 35 to 40, and that is what we have here, right? 58.
Yes.
So it is not for butanol, it is for propanol. Do you get this idea?
Yes.
And then this should be the base peak, right? And then this may be the M plus 1 peak, this may be the M plus 2 peak.
Okay.
Then what they have next is, so the mass spectrum corresponds to what? Propanol, this is what we have identified, right? Because the molecular mass is 58 and the butanol has a molecular mass of 72. Do you get this?
Yes.
Good. So then molecular fragmentation, it's not part of the syllabus, but just for your understanding, what I've compiled is, if you are breaking up a molecule, so we can have endless possibilities. We can have different possibilities. So these are all alkanes which might be broken up like this. They may have different, possibilities. We are breaking up an alcohol, so it may be something like this. So if we have originally we had methane, so methane might be broken up as methyl group. It can be ethyl, something like this and all. So it can move on. ठीक है बात समझ में आ गई?
जी.
Okay, good. So here there is an example of alkanes. तो आपको कैसे पता चलेगा कि किसकी पीक को किस तरह से रिप्रेजेंट करना है? तो यू जस्ट हैव टू सी कैलकुलेट द मॉलिक्यूलर मास. जहाँ पे भी जो भी मॉलिक्यूलर मास होगा वो आप आराम से आइडेंटिफाई कर सकेंगे कि भाई ये मॉलिक्यूलर मास इसका है तो ये वाली पीक ये होगी, यानी कि इसका मॉलिक्यूलर मास आपने आइडेंटिफाई किया तो यू कैन नेम कि ये वाली इसमें से ये वाली जगहों पे ये वाली पीक होगी.
Okay.
देन दिस इज फॉर एल्काइल हेलाइड्स. तो एल्काइल हेलाइड्स में अगेन मैंने आपसे बात की थी क्लोरीन की या ब्रोमीन की. तो अगर आपके पास ब्रोमीन है, सो ब्रोमीन के दो आइसोटोप्स होते हैं. एक होता है ब्रोमीन 79, दूसरा होता है ब्रोमीन 81. अब इनमें जो मज़ेदार बात है एज कम्पेयर टू क्लोरीन, क्लोरीन में आपको बताया था मैंने, एक था 37 और एक था 35. तो डिफरेंस आप देखो दोनों में दो का है ना.
Yes.
बट फर्क ये होता है कि क्लोरीन में जो 37 वाला होता है ये 25% अवेलेबल होता है नेचुरली, और 35 वाला जो है वो 75% अवेलेबल. जबकि ब्रोमीन में देर अराउंड 50 and 50%. ये मैंने इसलिए समझा दिया ताकि आपके जहन में रेशो 1:1 जाए. यानी कि अगर नेचुरली अकरिंग ब्रोमीन 79 देखा जाए और नेचुरली अकरिंग ब्रोमीन 81 देखा जाए तो एक 49% अवेलेबल होता है, एक 51% अवेलेबल होता है, तो 19-20 का ही फर्क होता है, दोनों हमेशा होता है। ठीक है, तो जब हम
ओके।
ब्रोमीन का कर्व आइडेंटिफाई करते हैं ना, बड़े आराम से समझ में आ जाता है क्वेश्चन। तो पीक हमेशा इक्वल हाइट की होती है, क्योंकि दोनों ही
ओके।
है नॉर्मली एक दूसरे में। लेकिन अगर हमें इस तरह की डेविएशन नजर आए, सही है, तो फिर हम आइडेंटिफाई करते हैं कि नहीं, ये ब्रोमीन नहीं हो सकता, ये क्या हो सकता है, ये क्लोरीन हो सकता है, क्योंकि एक ज्यादा है और एक क्या है, कम है। डू वी गेट दिस?
ओके।
देन वी हैव अल्कोहल्स। अल्कोहल्स के अंदर अगेन आप अगर किसी एक मॉलिक्यूलर फ्रेगमेंट को ब्रेक करते हैं, जैसे आप यहाँ पे ब्रेक कर रहे थे किसी प्रोपेनॉल को, ठीक है, तो प्रोपेनॉल का जो मास है, अब आप आइडेंटिफाई कर लेंगे अगेन वो किस किस तरह से ब्रेक हो सकता है। लेट्स से ये सिंपल प्रोपेनॉल था, इसमें से सिर्फ एक इलेक्ट्रॉन रिमूव कर दें अगर हम, तो ये बन जाएगा। फिर अब ये किस तरह से ब्रेक हो रहा है, मे बी इस तरह से ब्रेक हो रहा हो, मे बी इस तरह से ब्रेक हो रहा हो। तो जिस भी तरह से ब्रेक हो रहा है, हमें सिर्फ मॉलिक्यूलर मास से पीक आइडेंटिफाई करनी है, वो आपको मैंने ऑलरेडी बता दिया। ठीक है, देन
जी।
ये सिंपल 2-3 क्वेश्चन है, ये आप देख लेना, और बाकी फिर आप इसको अटेम्प्ट करना आप। बाकी अगर कुछ समझ में नहीं आए तो पूछ लेना। ठीक है, ये सारा
ओके।
डिस्कस या मैं आपसे स्लाइड्स आपको शेयर करूँ, बहुत आराम से अब आपको सारी बात समझ में आ जाएगी। जहाँ नहीं समझ में आए वहाँ मुझे बता।
ठीक है।
तो फिर हम बाकी जो आपका पेपर का डिस्कशन है, एक क्वेश्चन तो लास्ट रहता था, वो मैंने आपसे करना है। उसके अलावा जो नया पेपर अटेम्प्ट करना है वो मैं आपको भेज दूंगा, तो कल तक आप कर लेना, फिर कल हम उसको डिस्कस करेंगे। ठीक है?
सर अभी इस हफ्ते तो नहीं कर सकता, अब तो मैथ्स का पेपर आ रहा है, मैथ्स की तैयारी के उसमें, तो अभी अभी तो छोड़ दें। फिर अभी आप
क्या पेपर?
मैथ्स के 2 दिन पेपर है ना, एक साथ हो जाते हैं, उसका एक हफ्ते का गैप है।
आराम से, आराम से सांस लो जरा।
ठीक।
मैथ का पेपर 2 कब है तुम्हारा? पेपर 1 कब है तुम्हारा?
थर्ड को, और पेपर 2 जो है वो फिफ्थ को है।
और पेपर केमिस्ट्री का P2 कब है?
11th।
11 को है। तो
हम्म।
थर्ड को पेपर है ना?
जी।
उसके बाद 4 और 5 का गैप है, फिर 6 को पेपर है।
नहीं नहीं, फिफ्थ को पेपर है, 4 का गैप है।
एक दिन के बाद उसका पेपर है। तो आज है 28, 29, 30, 1, 2, 4 दिन में एक पेपर भी केमिस्ट्री का नहीं करोगे? एक तो कर लो चलो।
कर लूंगा, एक भेज दें, एक भेज दें, कर।
एक कर लो, सही है।
ठीक है, ठीक है।
फिर मैं तुम्हें तंग करूंगा 5 तारीख के बाद, सही है।
ठीक है, ठीक है।
फिर कोशिश ये करेंगे कि फिर रोजाना एक ना एक क्लास हो जाए, क्योंकि मैथ से तो तुम पारे हो जाओगे,
जी।
है ना। तो आई एम सेंडिंग यू दी स्लाइड, बस एक पेपर कर लेना, कल या परसों
हम्म।
में जब टाइम मिले डिस्कस कर, ठीक है।
ठीक है। ओके।
ओके, आई एम एंडिंग।